Hi everyone and welcome back. My name is Maor and I work at Experda.com, where we have specialized software to control, monitor and improve performance for SQL Server. In addition to that, we've decided to create a series of different videos about performance improvements in SQL Server databases. I have been a database administrator for the last 19 years and my specialty is in performance improvements. Today we're going to talk about calculated columns. Now, what is a calculated column? Sometimes, most of the times, we don't want to just select our columns as they are, but we want to add things to them. We want to have them embedded in a function. We want to have a calculation of two or more columns all together. For example, if we want to have a date column and we want to check if it's larger than a year from now, or we want to see the difference between two date columns, start of an event and an end of an event. Anything like that can be actually added to a calculated column. Now, why would we want to use that? The thing is that when we want the optimizer to use an index, any function or anything that we do with the column, when we're doing a filter, when we're grouping by, the optimizer won't be able to use it as an index. Therefore, when we have a calculated column, we can add that calculated column to an index. And just like with any video, I'm going to show you first hypothetically on the board, and then we're going to move into the Northwind environment of SQL Server, and I'll show you physically how the optimizer's decisions change according to that. So hypothetically, if we had a table 1 with columns A and B, which is integer and integer, and start, which is a date, and an end, which is also a date. And we would like to have a select. I'll change the color. With a where clause, having date diff of day, and then start and greater than 365 days, for example. And we want to take this thing and we want to create a calculated column out of it. What we have to do, now again, right now, this select statement cannot use an index. Okay? Even if you have an index on start and you have an index on end, it cannot use an index. However, what we can do is go alter table 1, and this is the syntax, add, and then we're going to add this thing as the column name. So let's say 365 diff, this is the column name, as this expression. So day diff, day start, end. Now this word says from now on I'm going to have a column that is 365 diff. That's the way it's going to be called. Now, anytime I want to insert to the table, if right now I'm going to look at my table is going to be A, B, start, end, and 365 diff. These are the columns. However, if I want to insert, I will only need to insert to these, because this one's calculated automatically. Now, what if my table was 2 billion rows long right now? The only time I will first extract this or use this in any way, only then will the records be inserted into this new column. What does that mean? It means that any time that right now I'm going to insert, as long as I'm not selecting or using it in any way, in a where clause or in a select clause, this column won't be calculated. Now think about it this time. Next time you're going to run and you have again a 2 billion row table, next time you're going to run an update on start or on end, this column is going to change as well. So this is like understanding that this is like another index insert, update, delete statements, in some way they're also touching that. But as long as you haven't touched either of these columns or you haven't touched the values, this is not going to change. So this is very important to understand. Another thing that you need to take under consideration, especially if you're just a database administrator and not a part of the programming team, is now from now on, if the software has selected select everything, and they were expecting to have 4 columns, now they're going to have 5. So take this under consideration. And I want to show you in the optimizer how the optimizer's decision changed and why we decided to do this. Now, of course, the calculated column or the composite column, we can calculate anything we want. Okay? So if our select statement used to be where column A times column B plus 5 is bigger than 750, we can put this whole thing, or we can do just A times B, or A plus B, or anything we want, A in the power of B, anything we want. The purpose is to see the composite expressions that we have, the predicates, and try to simplify them. Otherwise, a column or an index on A and an index on B are not going to individually help us. What we want is the whole expression, or we're trying to simplify our expressions as well. I'm going to make another video about simplifying the predicates in order for the optimizer to see that it can use different indexes. So that's it from now. Let's move to the computer. So, welcome back. So, we're taking our calculated or computed column example down to the computer. Here we're going to use the big NW, big Northwind database that we've created. And I want to show you the table that we're going to use. It's called orders. Orders is quite a thick table. It has almost 20 columns. We see the primary key is the order ID. And I'm going to teach you some cool tricks here. The first is when you are standing on any table, view, or object, and you can press Alt F1. And again, Alt F1. And then down here, you're going to see everything that you need to see about this particular table. So here we're going to see the name, the type, and then we're going to see all the different columns. And under that, we can see the identity, the different indexes. You can see I cleaned this table up, so we only have the primary key. And then you have the referenced by and everything. So in this example, we can see that we have a date add day -7 required dates. Now this is quite a common thing we see with date columns, that we're adding them inside a function and then we can't really index them. So what we're going to do here first, there's 2 tricks I want to show you. Set statistics IO on and set statistics time on. When you enable both of these, then from now on any statement that you'll make, we have the results tab and then we have the messages. And in the messages, you'll be able to see the total CPU time. So if we're going to just run this query quickly, you see the query succeeded, 2002 rows. And in the messages, you'll actually see. We'll take here the logical reads. We'll write before computed column. So we have 20,000 logical reads, and we have an elapsed time of almost 1 second. So that's 711 milliseconds. And what we're going to do is first we're going to create the computed column. So alter table orders, add, and then we'll call it orders required date 7 days as, and then we'll take this expression. We run this thing. Let's see what changed in orders. You will see again Alt F1. We see all the columns, and in the end, we have orders required date 7 days. Type is datetime, meaning it already knows the result of the function. Now we do want, for the first time at least, to just read all the values. And when we read all the values for the first time, this actually means that we don't have to read them in a surprise. Meaning the first time we initiate, and then we know that in any update or in any delete statement, these values won't be have to calculate it in real time. And now we're just going to add an index. Create an index. We'll call it ix1 on orders. Now, because we want to check without the buffers, meaning we know we have SQL Server has its own internal cache. If we want to check, we'll have to clean those buffers, and we'll use the drop clean buffers command. And again, remember, anything that we run now, we can actually see the changing execution plan. In the execution plan, we see that we're using the new index, the orders underscore required 7 days ID days ix1 index. And in the statistics, let's see, after computed column statistics, we can see that we have a logical read of 9,000 and a total execution time of 345. So that's almost 50% improvement in logical reads and almost a little bit better than 50% in the total elapsed time. And what we did here was actually just use the computed column. Now we need to remember, just like I said, we need to remember if we're inserting into this, if we're inserting a new record into this table now, we need to remember that we have a new column. So again, if we're retrieving using the select asterisk many times in our system, which is not a healthy habit, we also need to remember that from now on we're going to have another column. So that's all in computed columns. This is a very, very short and simple example. Obviously, you can make many of your different examples or complicated examples, or having more than one column or having more than one function in a computed column, anything you want.